here's some quick notes about what the operation factorial means. The notation for factorial is an exclamation point, and we would read that n factorial. And what it is the product of n and all natural numbers preceding n. So for example, if we wanted to calculate 5 factorial, we would want to calculate the product of 5 times 4 times 3 times 2 times 1. 1, 2, 3, and 4 are all natural numbers that precede 5. So it's basically multiplying all those numbers down to 1. Now, of course, we don't really need to multiply by 1, because anything 1 times 1 is itself. This product is actually equal to, I believe, 120 if you multiplied that out. Your calculator does have a factorial key. I believe it is under Math, and then when you hit the Math key, you would arrow over to PRB on the top, and then I think it's choice 4 for factorial. So that might be fun to play around with. Actually, if you do have your calculator handy, it might be nice to try this. If you try to calculate 100 factorial, your calculator, well, if you're using the TI-83 like I have, it'll probably tell you this. Error, overflow. That means that the number you tried to calculate was just way too big, and that should make sense. You just ask the calculator to do 100 times 99 times 98 times 97, etc., all the way down times 3 times 2 times 1. And that the calculator could not do that. It was too big. So there are some values where it's just nicer to leave as 100 factorial. It's going to be some giant number. So it's nicer to just look at it as 100 factorial. It is interesting, though. We are able to calculate this. If you put this into your calculator as 100 factorial over 97 factorial, again, it'll give you error overflow because it's going to try to calculate each of the numerator and denominator before it tries to divide. But let's write out what this actually means and see if we can use the definition of factorial to try to simplify things before calculating them. 100 factorial is 100 times 99 times 98 times 97 times 96 times 95. Don't worry, I'm not going to write all of them out. I'm going to do dot 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 times 3 times 2 times 1. I got a little lazy. Divided by 97 factorial. 97 times 96 times 95 times 94. I'm lazy. Dot 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 times 3 times 2 times 1. Do you see any common factors in the numerator and the denominator of this fraction? There's a lot of them. 3, 2, 1, 97, 96, 95. Actually, everything 97 and below will cancel. So that quotient is really just equal to 100 times 99 times 98, which is not too large for the calculator. We could actually figure out what that number is. I don't really care to right now. I'm going to leave it like that. Another thing that's important to note about factorial is the order in which you would calculate factorial. We all learned PEMDAS or whatever, as order of operations, but where's the F for factorial? Where does that come in? Let's investigate. Is there a difference between 2 times 3 factorial and the quantity 2 times 3 factorial? What this first one says to do is 3 factorial first and then multiply by 2. 3 factorial is just 3 times 2 times 1, which is 6. Times 2 would then give us 12. 2 times 3 first, on this second example here, would really be 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, which is definitely not 12. So these two things are not the same. That means it is important to recognize when to do factorial first. If there are no parentheses, it means that the factorial would be calculated first. In general terms, I guess we could say something like ax factorial is not always the same as the quantity ax factorial. So it's important to just pay attention to that kind of thing. One other thing that's interesting to note is that 0 factorial is actually defined to be 1. You might think that factorials are only defined for natural numbers. Turns out we actually have a definition for 0 factorial, and that it's equal to 1. And that's just a definition. We just have to take it as something we know to be true. And you'll see why when we're doing formulas involving factorial, why it's important that we have that definition. But we do 0 factorial is equal to 1. There you go. Have fun with factorials.